are waiting. Ayan. Okay, once again, class, good morning. So today we will discuss about the different processes of vapors para maintindihan natin ang Rankine cycle as well as the different vapor cycles, lalong-lalo na yung pinakauna nating cycle. Okay? So thank you for coming. I know yung iba may klase, but thank you. So okay, let's start class. Okay, thank you. Okay, so kung last time we discussed about the constant pressure process. Now we continue with the constant volume process. So take note class, yung sa constant pressure and the constant volume, okay? We continue. So number 2 to class, the constant volume process. So ano class yung constant volume process? If we have the constant pressure process, anong tawag doon? ISO what class? ISO? Ano class yung constant pressure process? Anong tawag doon? Di ba nakuha nyo last time?
Isobaric, ma'am.
Okay, thank you. So that is isobaric. So sa constant volume process class, tinatawag din siya na isometric process. Okay, pwede din siyang isometric process. And also isochoric process. Okay. So that is now the constant volume process. So pag pinadraw class, the first one is the process on the PV and the TV plane. I mean in the TS. Okay. So bakit pinapakita ko to palagi? Para pag nag-draw na kayo ng schematic diagram during cycles, alam niyo na. Okay? So we have the PV diagram. Okay, class. Palagin nyo nito yung PV diagram natin, ha? The PV. Ayan. Automatically, class, ito class na area na to. Alam nyo na to dapat. This is the subcold. Ayan, or the compressed region. So, yan. Sa gitna naman, class, ang tawag naman dito is yung, nasa loob, class, is yung wet mixture natin. Ayan. And also, dito, class, is yung, ito, class, is yung superheated region natin. Sa labas. Okay? So, in a PV diagram, in a constant volume process, automatically when you see constant volume process, straight line in class. So, from here, for example, the superheated region yung point 1 natin. And this is a constant volume, so automatically 2. So, your specific volume at point 1 is equal to the volume at point 2. Kaya constant volume process. And also, in the TS diagram class, ayan. In the TS plane, so, ayan. So, iba na siya class. So, ito yung constant temperature natin, as well as yung constant pressure. Diba? Yan ito yung class. In a volume, Tapos ito nito. Ayan. From point 1 to point 2, dito class, constant pressure ang nangyayari. Dito is constant volume. So the shaded portion class in from point 1 to point 2 here in a constant volume process, ito class, excuse me, ito, yan. The shaded portion class is always the heat. Okay? Yung Q natin to. Take note of that. Pag sa TS class, pag may shaded portion ka, palaging heat yan. While in the PV, palaging work. Since from the figure, yung sa PV natin sa constant volume process, we all know that this is a constant volume. So automatically, kahit sa figure pa lang, makikita mo na ang work niya na is 0. Kasi walang shaded portion, right? Compare sa PS plane natin, we have the shaded region from point 1 to point 2. That is now the heat. So, meron tayong heat. Okay? So, this is a reversible constant volume process. Okay? So, sabi ko nga, sa letter, sa PV plane, okay, wala tayong work sa non-flow. Okay, the non-flow work. Ayan. Okay. So, this is the work of the non-flow process. So, from the figure itself, wala talagang work ha. 0 sa constant volume process. As well as sa letter C, we have the transferred heat. Ayan, yung heat natin as Q, labeled as Q. Okay, so balikan natin yung simple energy equation we have here. The heat is equal to the internal energy at point 2 minus at point 1 and also the work of the non-flow. Since ang work non-flow natin is 0, automatically, yung transferred heat natin is from the internal energy at point 2 minus the internal energy at point 1. Okay? We can also make use of the equation class, but sometimes we can use this. Pero kung hindi siya given class sa problem, kung given na sa atin, yung i-derive mo class ng H. Okay. Wait. Yung enthalpy natin is equal to the PV plus U or the U plus PV. So we can use of this equation also. The enthalpy at point 2, the pressure at point 2, and the specific volume at point 2. Kasi minsan kadalasan sa solution, yung volume refers to the specific volume. Okay? Kasi steam table yung gagamitin natin. Okay, class, that is now the enthalpy and also the point 1 minus the pressure at point 1 and the specific volume at point 1. So how do we can apply this? So an example, is example natin sa constant volume process. Excuse me, class. Okay. So dito muna tayo. Okay, though, from example, so 1 kilogram of steam, 260 degree, with an enthalpy of 1861 kilojoule per kilogram is confined in a rigid tank. Rigid tank or irrigid? In a rigid container, so heat is applied until the steam becomes saturated. Okay, so take note of the word saturated. Okay, we need to determine the heat, the change in enthalpy, and the change in entropy, as well as the final temperature. Okay. Paano mo malalaman na constant pressure process yung binigay sa atin? Kasi sa problem, makikita nyo class the word confined in a rigid container. Okay? Ibig sabihin, andun lang siya, constant yung volume natin. Naintindihan? And also, another keyword is the heat is applied until. So, this is now your point 2 state points o saturated na. Okay. Steam becomes saturated. Okay. Let's start solving a solution. Nasa tabi nyo ba kasi yung steam table niya? Raise your hands if you have your steam tables. Sige nga. Okay. 7, 13. Sige. Still counting. Ayan. Okay. Thank you, class. So, let's start the opening of our steam table today. So, di ba class, sabi ko nga, pag dito sa example, hindi naman sinabi that show the PV and the TS diagram. So, sa solution, palagi yan, andyan ha. Okay. So, take note, sinabi dito sa problem, 260 confined and a rigid space. So, we draw now the PV. Paano po yan, ma'am? Okay. Di ba class, sabi sa problem, ano daw class? Confined in a rigid, constant yung volume until saturated. Hindi sinabing saturated, but automatically papunta yan na saturated vapor. Okay. So, mamaya, titingnan natin. So, i-draw nyo muna yung PV and the TS diagram. Yan. Pero hindi mo pa alam yung mga state points. So, mamaya muna siya i-draw kung saan yung mga state points. I-ready mo lang siya. Okay, TS. Okay, let's start. Okay? So, punta tayo sa state 1. Okay, sa state 1. Ano yung given sa atin, class? State 1. Ang given sa atin, the given is the temperature at point 1 is equal to 260. Ayan. Palitan natin ang kulay. Blue na lang yung solution natin. Okay. So, take note. Ayan. Temperature at point 1 natin is 260 degrees Celsius. And yung given na enthalpy natin is 1,861 kilojoule per kilogram. Okay, saan ka pupunta? If you have this, considering na nasa isang rigid container, ibig sabihin, from point 1 to point 2, constant yung volume natin. Okay? Okay. Saan pupunta? Ayan na. Narinig yung steam table, ma'am. Anong table? Punta tayo sa table. Table 1. Okay, page 6. Okay? Page 6. Okay, nakasunod ba lahat? Table 1, page 6, 260. Ayan. Table 1. Ayan. Nalagyan ni ma'am para yung iba makasunod pa rin pag nireview. Okay, take note sa 260. Yung Hg natin is mas malaki. 279.9 kilojoule per kilogram. We have also the HF. We have 134.37 kilojoule per kilogram. Parehas ba sa nakuha nyo, class? Raise your hands. Kung parehas. Ayan. So, na-notice nyo that the given, yung HF natin, malaki pa rin yung given natin, but hindi siya lalagpas sa Hg. Sabihin, sa imbawa, ito yung TS diagram natin. Example lang ha. Yan. Yung TS natin. So, this is the F. Hindi ko nga dito. Ayan. Ito, class, take note. Dito yung F mo and this is your G. Ibig sabihin, yung H1 natin, magpo-fall under this area. Okay? So, dito yung 0.1 natin. Naintindihan? Yan. Dito yung 0.1. Kasi nasa gitna yung values niya. Diba? Approximately. So, ano yung gagawin natin? Para makuha natin yung sa 0.1, we will move on to the ano class yung gagawin mo? Pag alam mo na siyang wet mixture siya. Ano po yung kaya?
Quality po.
Yes. Okay. So, kunin na natin yung quality at 0.1. The quality at 0.1. Okay? So, yun yung hahanapin natin. So, you found your quality at 0.1. Fg at 0.1. Okay? Quality at 0.1 now is equal to the, yan. Yung HFG class ando na sa table, huwag na tayo magma-minus. Okay? Ano yung given sa atin? 1.861. Sige, compute nyo na. Ano yung HF natin sa 260? Excuse me. 37. And also the HF1 is 1,662.5 kilojoule per kilogram. What is now your quality? 4 na decimal. Sige. Chat nyo na class sa chat box. 43. Yung iba. Yung iba class. Ayan. Sige. So we have now 2.5. So we have 0.4371. So approximately 43.71%. Yan. Thank you, class. Okay, so we have now the quality at 0.1. But take note, hahanapin natin yung mga specific yung specific volume niya as well as yung enthalpy and the entropy. Okay. So, punta na tayo dito sa finding the internal energy at 0.1. So, gagawin nyo to plus the quality, the VFG at 0.1. Yan. Specific volume to class. The quality at 0.1. Yan. Okay, what is now your specific volume at 0.1? So, sa steam table natin, doon pa rin tayo sa 260, we have 42.21 times 10 to the negative 3. Ay, mali. VG pala to, class. This is VG. Ayan. So, balik tayo dito. We have 1.2755 times 10 to the negative 3. Ayan, ha. Ngayon, pag-present ng solution nyo class sa akin. Plus the quality. VG. What is VG? 42.21 minus 1. Baliktad na class times 10 to the negative 3 cubic meter per kilogram. Okay. What is your specific volume? Sige nga. Compute din nga ni ma'am. Huwag kakalimutan yung times 10 to the negative 3, ha? 1.2755. 71 times. Sige nga, what is your answer? 0.2755. What is your answer? May answer na ba? Tingnan sa chat box. Ayun. 19.17. Okay, yung iba, I'm waiting for the answer. Okay, so we have 19.168 times 10 to the negative 3 cubic meter per kilogram mass. Okay. We have now the specific volume at 0.1. Proceed to the enthalpy. Proceed at the enthalpy at 0.1. Enthalpy at 0.1. Okay. Plus the quality UFG at 0.1. Nilalagyan ko na class, ha, ng quality at 0.1. Yan. 260, what is UF1? UF1. We have 1128.39. Quality 0.4371. 140.6. Find the internal energy at 0.1. Sige nga. 1128. Ayan. Times 1470.6. Ano na, class? What is your answer? Wala pa. Sima mo na una. 189. 19. Bakit iba-iba yung answer natin? Ano yung answer nyo? Class ng iba? Ayun. Akala ko. Yeah. So we have the internal energy at 0.1. Finding also in the entropy at 0.1. So ganun yung class. Ulit-ulit ka lang yan. Master mo na to. Balik ka ulit dun sa steam table. Yan. Dito tayo, class. Sa entropy. 2.838 kilojoule per kilogram Kelvin plus 0.4371. Entropy natin, 3.1181 Kelvin. So, we have now the entropy at 0.1. 4 decimal tayo, strictly 4 decimal sa entropy. Yeah. Ayun, dali-dali naman nilang magsagot. Oh, Parehas ba yung sagot nyo? Tingnan ko nga. Tingnan din ni ma'am. 4071 times 3.11, 81. So we have now 4.2467 kilojoules per kilogram Kelvin. Yes, we have solved everything. So nakuha na natin class, di ba? Okay. So if we read again how do you call this? If we read again the problem, what is now the property, the state point at point 2, the state at the point 2? We all know, sabi sa problem, constant volume. Bakit? Sabi, may word na rigid container. Pero sinabi doon, until ano class? And heat is applied until the steam becomes saturated. Becomes saturated. Pero ang gagawin na natin, we all know constant volume equal na yon. So yun magiging basis natin at point 2. Okay? Point 2. Ayan. So, saan ka pupunta na table? Sige nga. 168. 19. Anong table ka pupunta? Until it becomes saturated. Sige nga. Sige nga. Saan ka pupunta? Saan ka pupunta, class? Ito yung basihan mo. Saturated daw. Heat, ano? Sabi dito, the heat is applied until it becomes saturated. Becomes saturated. Ano yung gagawin natin? Sige nga. What we will do, class? Kasi sa problem, sinabi, until it becomes saturated. Hindi na yung dati na may guide pa tayo. So, saan ka pupunta? Saan ka hahanap? Yan. Class. Any guess? Sige nga. Table. Table ano? Tapos ano? Table 3. Yung iba, anong guess? Table 3. Yung iba po, class. What is table 3? That is a superheated region. So, hindi pwede doon. Okay, class? Saturated. Hindi kadalasan naging saturated liquid yan. More likely, nangyayari is saturated vapor. So, yung quality natin, 100%. So, ang V specific volume at point 2 is ganito dapat. Equals sa VG. Okay. Saan tayo pupunta? Okay. Punta ulit tayo dun, class, sa table 1. Table 1 pa rin tayo. Table 1. Bakit table 1 pa rin? Sige nga. Table 1. Pero anong hahanapin mo sa table 1? Kasi temperature din yung given natin. Pero ngayon, ang state point na natin is yung same temperature pa rin po ba hanggang maging saturated? No, hindi na po siya same temperature. Ang mangyayari na lang, ang constant lang is yung volume. Kasi kung sinabi kong constant yung temperature, that is a isothermal process. Okay? Ibig sabihin, class, you will find or hahanapin mo yung values sa table wherein 19.168 cubic meter per kilogram, ito na, hahanapin mo sa table 1, pero ang hahanapan mong table, column, tama ba? Column ba to? Column is yung column na ng saturated vapor. Yung VG mo or specific volume. Specific volume saturated vapor. Sige nga, hanapin niyo VG. Kasi sinabi sa problem, until it becomes saturated. Hindi pwede sa point, sa table 2, kasi saturation pressure yon. As well as sa table 3, hindi naman sinabing superheated region siya. Pero kung sinabing superheated region siya, hahanapin mo siya doon sa table 3, wherein yung value is ganyan. Okay, nahanap nyo na, class, kung anong page siya sa table 1. Yung specific volume wherein yung saturated vapor natin is nagpo-fall under the column ng VG na ang value is 19.168. Okay. Page 7. Tingnan nga ni mom siya. Okay. Okay, so, okay, class, nakuha nyo na. So, punta kayo doon sa page 7. Yan. May mga between pa kayo. Di alam nyo na, class. Perfect na exam ni ma'am. Okay, punta kayo dito sa table 1, page 7. Ang temperature niya is between 306 and 307. Why? Yung specific volume niya at saturated vapor, ito 19.1619. Okay, ang unit times 10 to the negative 3 cubic meter per kilogram mass. And here, kung ayaw nyo, class, lagyan ng unit sa baba, dito sa taas. Okay? Pag mag-present ng solution. 19.294. Ay, bakit 306? Units, no? 168. Ay, 307 pala, class. Naduling si ma'am. 307, 308. Okay? Ayan. 307. Ayan. Ulitin. We have 307 and 308. This is 19.294. Sa baba is 18,975. Bakit? Kasi yung given sa atin at specific volume at point 2, ito yung V2 niya. 19.168. Okay, so nagpo-fall to, class here. Nagpo-fall yung state natin, the constant volume at point 2, nagpo-fall siya between this value na 19.294 cubic meter per kilogram mass times 10 to the negative 3, okay? And also the 18.975. Ibig sabihin, hahanapin na natin yung iba niyang state points wherein yung temperature natin, yung internal energy natin, the entropy. Okay. So, ano na yung class yung magiging basihan mo dito? Okay? Mag-interpolate na tayo dito, class. Interpolation. Okay? To find the value at point 2, that the final temperature at point 2, and also yung sa iba. Okay. So, 307 class. Ano yung gagamitin nyo, class, sa internal energy? Internal energy. What column? Sige nga, i-chat nyo nga. Anong column yung gagamitin nyo? Para ma-interpolate nyo. Class. What column? Sa internal energy, UG. Okay? Yung iba, ay wow, in-input na yung very good. Okay. So, we have now, kukunin natin class is yung internal energy, saturated vapor, UG, in kilojoule per kilogram. We have also the HG, kasi sinabi until it becomes saturated. Okay? So, in kilojoule per kilogram. And the entropy at saturated vapor, kilojoule per kilogram Kelvin. Okay. So, doon na tayo doon sa internal energy at saturated vapor. We have 255.1.8. Sa baba niya is, plus dapat may ruler kayo ha. Kakaduling to na steam table. 0.1. Sa HG naman, we have 2724. Ay, 2734. Ayan, naduduling na si ma'am. 2734.3, 5.6417. Sa baba, we have class paki-double check na lang pinagsusulat ni ma'am. And we have also 5.6397. Okay. We need now to interpolate to find the values at state 2. Okay? So, interpolation, sa iba, baka hindi pa alam, ulit-ulitin ni ma'am. You have A, B, C, the Y, the X, and the Z. So, B minus A, C minus A, X minus Y, and Z minus Y. Okay, so you need to interpolate B minus A, C minus A, X minus Y, and Z minus Y. Okay, interpolate na class at T2. What is now your in temperature 2? Ano yung magiging value natin? So, ito magiging basis natin. 168 times 10 to the negative 3. Ay, wow. Galing class ha. Meron na kayong sagot. Okay, pakita lang natin sa mga classmates natin. 294 times 10 to the negative 3 per kilogram divided by the say. Pakita ko lang class ha. Maiguson pa si mamang sur. Pag nag-solution ka mo kasi filing po ini ha. Sa exercise, ma'am. Per kilogram times C minus A. C minus A. What is C? Times 308 minus 307 degrees Celsius. Mayayari, plus or minus? Plus A. What is A? 307. So, what is now yung temperature to? Ano na, class, tingnan ko asa siya. 307.39. Tama ba? Yung iba, what is your sagot? Sagot. 19.168 minus 19.294. Huwag kakalimutan na yung 0.975 minus 19.294. Okay. We have no B minus 30. Class, bilisan nyo yung pag-solve nyo, ha? Bilisan. Opo, class. So, make it right. Ayan. So, what is now the A? So, we have 307.39 degrees Celsius. So, this is now the temperature at point 2. 0.39. Okay. Sa kabila naman, class, sa internal energy at point 2. Okay. Shift solve na lang si ma'am. Okay, kayo, what is your answer, class? This is now your A. Ang magiging basehan nyo palagi, class, is yung given para hindi kayo malito. Okay? 2551. What is now your answer? Find ways kung paano nyo yan mapapadali. Hindi na ituturo ni ma'am. It's for you to discover. Ayan. Ano answer nyo, class, sa enthalpy? Tingnan ko ako meron. Oh, wala pa. Ay, enthalpy. Enthalpy. Internal energy. What is now your answer? Internal energy at point 2. Ayan. O, bakit iba-iba? 2 decimal. Yung iba? 2, 2, 2. Yun, may nakita na ako. So, the internal energy at point 2, computation ni ma'am is 2551.13 kilojoule per kilogram. Okay, so this is now 13. Punta tayo sa point 2 ng enthalpy. Enthalpy. Okay, enthalpy, class. X minus 27.3. Ay, wow, may answer na. Dali-dali naman yung class, ha. Okay, sabi mo, ma'am, bilisan namin ang pag-compute. Okay. Okay. 2733. Tingnan ko ang mga answer niya. Point. Yan. So, we have 2733.40 kilojoule per kilogram. The entropy at point 2. Ang answer natin dito. Ayan. Entropy. Entropy na tayo, class. Move on to the entropy. Gamitin nyo kasi yung calculator nyo. Ay, wow. Ang dadali. Sige. 5.64. So, what is my answer? Ayan, nakuha niya, class. Very good. 5.6447 kilojoule per kilogram. So, we have now, may kulang na unit. Kilojoule per kilo 7 to. Kelvin. Okay. Kelvin ba yan? Kelvin. Okay. So, yes, nakuha na natin yung 8 points. But what is asked in the question? First, we need to find the, ano yung pinapahanap sa atin, class? We have now the heat. Ano yung gagamitin natin? Since the work, alam naman natin na internal energy plus the work. Since the work is 0, so we have now the Q, U2, the internal energy. Okay, What is internal energy at point 2? 13 minus at point 1. 1771. Ayan. Pakisolve nga class ng transferred heat. Okay. Oh, wala. Si ma'am na nga lang. Minus 1771.19. Answers nyo. In transferred heat class. Ayan. Thank you. Wow. Ayan. Magpa-perfect na exam. Ayan. Binibilang naman kung ilang nag-participate. Madami. Thank you, class. So, the answer now is 779.94 kilojoule per kilogram. Okay? And in letter B, ano yung pinapanap sa atin? Now, we have to find the enthalpy, the change in enthalpy. We have the enthalpy at point 2 minus the enthalpy at point 1. So, we have the H2, 2733.4 kilojoule per kilogram minus the H1. H1, what is the H1? Yan, naririnig. Hindi natin kinompute yung H1. Given pala sa atin yung H1. 1. Okay? The 1861 kilojoule per kilogram. So, the change in enthalpy. What is now the change in enthalpy? 2733.4 minus 1861. 1861 rin. Okay. Ayan. Dami-dami. Yes. Yes. So, the answer now is 872.4 kilojoule per kilogram. And sa letter C, pa-perfect yung class ng aking exam. Latsado. Okay. Letter C, we have the change in S, the entropy at point 2 minus the entropy at point 1. Entropy, 5.64 per 7. Ayan. Minus S1. Okay. What is now the entropy? Entropy. Wow, dali. Dali. Class mag-solve. 447 minus 4, 2767. Thank you, class. So, 1.398 kilojoule per kilogram Kelvin. Yes, may points na kayo. 3 na yung points niya. Kasi yun palang pinapahanap. And letter D, pinapahanap sa atin is now the final temperature. So, we're in, ano yung final temperature natin? Sige nga, hindi ko i-scroll. Ano yung final temperature natin? Kung nag-notes kayo dyan sa inyong maliit na notebook. What is now the final temperature? Wala. Final temperature, the state point, ayun. Yung notes. Wow. Okay. Thank you, class. So that is correct. So the temperature at point 2 now is here. Ayan, class. So, ayan yan. Yan. Very good. So we have now the temperature at point 2. So, perfect yun na yung exam. Ayan. Ganyan lang naman kasi yung pagdadaanan mo para sa isang puntos. Okay? May kulang pa. Walang points yung ano nyo, PV and TS diagram. So, kanina, we have computed that the quality is on, the first point is on the, ilan percent? 43. So, dito yan. Hindi siya sa kalahati. So, mga dito yan. Okay. So, this is now your point 1. Layo ng point 1 natin. Ito. Halimbawa, ito class yung, wait. Diba ito yung hanggang 100%. Kalahati ito, 40 dito. This is now your state. The point 1. So, this is a constant volume papuntang saturated. Ayan. So, dito yung point 2 natin. Diba? Tama. Kasi sinali sa problem until it becomes saturated. Dito naman sa kabila, so, 40 kalahati, ito 40 plus. Dito yung point 1 natin until it becomes saturated. Tama ba? Ay, mali pala yung ano ko. Tama, ito yung linya natin. But, since this is a constant volume, di ba? Nagkukurba siya, class. Ayan. Until it becomes a saturated. Ayan. So, papunta yon. Papunta doon yung point 2 natin. From this point to that point. So, hindi straight line yung sa constant volume natin. Okay? Naintindihan ba kasi yung constant volume? Right or wrong? Wrong or right? Right or correct? Okay? So, okay? Let's proceed class now to, sige, raise your hands if you understand the constant volume process. Madali lang, class. So, ibig sabihin, class, hindi lang sa kung saan lang yung temperature lang yung hahanapin mo. So, pwedeng saturated liquid, saturated vapor. So, yun yung tricky part. So, hindi palaging si pressure ang given, hindi palagi si temperature ang given, hindi palagi si pressure. Kasi ang sa table natin is all saturated pressure and saturated temperature, saturation temperature. Okay, madami pang example dito. Okay, let's proceed now to, if we have the constant volume process, proceed to the isothermal process. Okay. Ayan. Okay, we proceed now to the constant temperature process or tinatawag nating isothermal process. Okay? Huwag kakalimutan kasi mga terminologies. Okay? So, ano yung letter A natin? Yung process ng PV and the TS plane. Okay? So, ulit-ulitin kahit magsawa na kayo nito, class, pero all throughout my subject, ganito talaga. Palaging may PV and TS diagram. Make your solution clean. So, para mas madali ma-point sa ano, ma'am. Lalagyan ng points. Yan, the PV. And we have also the TS diagram. Ayan. Okay. Take note sa PV. Ang baba pala ng ano. Okay. Dapat mataas. Ayan. Sa PV class, sa constant temperature, given sa atin yung red na lang. . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 . 1 of pressure at point 1, pressure at point 2. So, kadalasan, pag constant pressure, constant temperature or the isothermal process, ganito yung processes class. Kadalasan superheated and papunta siya doon sa saturated liquid line. Okay? And pwede mixture siya. This is just a representation of the process of the isothermal process. And proceed na tayo dito sa TS diagram natin. So, meron na tayong shaded portion. Okay? Ayan. Ibig sabihin, may work tayo dito na nangyayari. May work dito, class. Ayan. May work. Ayan. Punta tayo dito sa TS diagram. So, we have point 1, point 2. Okay? So, given sa atin yung pressure at point 2. Diba, class? Ganito yung constant pressure. Makinig, class, ha? Ganito yung constant pressure natin. Ay, bakit to? Ito. This is a constant pressure. Point 1 yan, pressure 1. Ay, pressure 2. So, ito naman yung ay, mali, class. Mali dito. Kasi constant pressure, ganito dapat. Ayan. Pag constant pressure, ganyan, class. But since sinasabi dito that we are in an isothermal process, constant yung temperature natin. So, straight line siya. Ayan. Doon sila mag-meet. Ayan. So, this is now your point 1 and this is now your point 2 at given pressure at point 1. Diba? Iba yung pressure niya, iba yung pressure at point 2. Okay? So, anong mangyayari? We have the entropy at point 2. So, kung ibababa natin to, ito class yung entropy at point 2 and papunta dito sa pinaka that is now your entropy at point 1. So, the shaded portion, ito yung shaded portion natin. Ayan. Is now your, this is now your Q. Ay, hindi kita. Ito na lang. So, this is your Q. Ay, hindi din kita. So, yun class from the table at a constant temperature. Specific. The entropy now is equal to the 2 minus S1. Okay? S2 ba? Okay. So, minsan class negative, minsan positive. So, depende sa point from point 1 to point 2, point 2, point 2. Okay. The change in TS. So, kadalasan Q is equal to T times the change in S. Okay? So, that is now the constant temperature process or the isothermal process. So, ito yung work non-flow natin meron. Okay. We proceed since, excuse me, class. So, yung workflow natin at this point, at this process. So, from simple energy equation, class, yun na lang gagamitin natin. Energy equation natin na the work is equal to the Q minus change in. Isa dyan kinuha ito. Diba? So, dinerive lang ito na yung ginamit niya. Yun yung transfer heat natin in a constant temperature process. The Q, since constant yung temperature natin, the T times the change in entropy, kilojoule, or kadalasan S2 minus S1. That is the entropy. Okay. Pero kung sinabing hindi siya na-flow pag steady flow class, ito yung formula. Hindi ko na i-direct class process kasi madami pa tayong processes na pagdadaanan. Okay, so we have a Q minus the P minus the kinetic energy. Oops. Bakit nag-bug ba yung ano ko? Ay. Okay. Okay. So, what is the example here in constant temperature process? So, this is an isothermal process. Okay. Sige. Dali. Okay. So, steam at 200 degrees Celsius and with an entropy of 5.6105 kilojoule per kilogram Kelvin. Yan. Expands isothermally to 0.515 MPa. Yan, for a 5 kilogram. So, may given tayong mass. Ang tanong sa atin, what are the change in S, the change in H, and the change in internal energy? We need to determine also the heat and the work. And for a non-flow process, hahanapin natin yung heat and internal, and also for the steady flow process, wherein yung change in kinetic energy natin. Kinetic energy is 0. Okay, so what is the first step? Solution. Ano yung pinakaunang gagawin natin during this? Take note of the word expands isothermally. Ibig sabihin constant yung temperature natin. So, the temperature at point 1 and the temperature at point 2 is equal to 200 degrees Celsius. Okay. Ano yung gagawin natin una? If you have this, sabi ko, i-draw nyo muna yung always draw pero babalikan nyo mamaya the PV and the TS diagram. We have now the TS diagram. Okay. First step. Given sa atin yung steam at temperature 1, 200 degrees Celsius. This is a isothermally. This expands isothermally, so automatically temperature at 1 is equal to temperature at 2. Wherein yung temperature natin is constant. Okay. Okay, equal siya at point 1 to point 2. So, ano yung pangalawang condition na binigay? Entropy. So, at point 1, we have entropy 561. 561.05 kilojoule kilogram Kelvin. Punta sa table. Anong page? Sige nga. Table ano? We have 200. Class, anong page kayo pupunta? Given sa atin yan na entropy and temperature. Okay. Okay, nakukuha na yung Okay, thank you class. So, acknowledge po yung mga answers niya. So, punta tayo dun sa table 1, page 5. Ayan. So, at table 1, what can you conclude from the entropy that was given at point 1? Ano siya? Saturated, superheat, or wet mixture? Table 1 G is 6.2323 and the SF is equal to 2.309 per kilogram. So, thank you class. So, you all notice that the entropy of the saturated liquid is greater than the given entropy, but it is less than the saturated vapor, the entropy of the saturated vapor. Therefore, nagpo-fall siya between those values. So, that is wet mixture. First thing we need to solve is the what class? The quality at point 1. Okay? So, finding for the quality at point 1. Ayan. Dapat master yun na to class. SFG at point 1. Finding for the quality. S1. SFG. Point 1. What is S1? Given sa atin sa problem, 5.6105. Ayan. SF1, 2.3309 kilojoule per kilogram Kelvin divided by the SFG1, which is equal to 4.1014 kilojoule per kilogram Kelvin. So, we have now the quality at point 1. Sige nga, saan yung calculator ni ma'am? What is now the quality at point 1? Diba, class? Madali lang term mo. Minus 2.3309 4.10 19 14. What is now your quality? Yeah, very good class. So we have now 0.7796, approximately 77.96%. Ay, 76. Bakit 77? 79. Ayan, that is 79. 79. Ayan, very good class. Okay, so that is 79.96. We have now the quality at point 1, but in the given problem, we need to solve for the other properties. Am I right? From this, we will solve now we have now the entropy. Then, we move on to the enthalpy at point 1. Okay? Okay, enthalpy. What is enthalpy? HF 852.45 plus 0.7996 HFG. Ay, may answer na. C class. What is H1? Other classmates. 45 plus 0.7996 times 1940.7 May nakita na akong mga answer. Ano yung answer niyo, class? Yung iba? Dalawa pa lang. Okay. So, nasusundan ba si ma'am? Nasusundan? Baka hindi niyo ako nasusundan. Kukulitin ko kayo, class. Okay. So, we have now the enthalpy at point 1, the 2, 4. Bakit? Palaging mali si ma'am magsulat. 2, 3, 2, 3 kilojoule per kilogram. Okay, we have now the each. We move on to the internal energy at point 1. Yan, dapat mabilis na kayo lang yan. UF. UF1. What is UF1? F ha, hindi G. 850.65 plus the quality 1744.7. We have now the internal energy at point 1. What is the internal energy at point 1? Sige. Sige. Kung tama. Sige nga. Baka mali class. Double check your answer. Okay. Sayang ng points. Okay. So, the answer is 2, 2, 4, 5, 71. Yan. Nakukuha nyo na class. Diba madali lang? Okay. At state 1, we need to also find the internal or the specific volume at point 1. Specific volume at point 1, we have this. Excuse me, class. 65 times 10 to the negative 3 cubic meter per kilogram mass. Plus the quality. Okay, minus natin yung VG. Kasi wala namang direkta. 2736. 1.1565. Huwag kakalimutan yung times 10 to the negative 3. Okay? So, what is now your specific volume? Sige nga, si ma'am. Day kami tinuturuan. Shortcut. Okay, it's for you to discover. Okay. 0.36 minus. Okay, what's your answer? 102 point. Okay, we have now the state. Ayan. Thank you, class. Nakuha ng lahat. Okay, nakuha na ba, class, lahat? So, that is now the state points at point 1. State pa lang yan. Wala pa yung aray. Yung final answer natin, wala pa yung pinapahanap sa problem. Ayan. Expands isothermally to 0.515 megapascal. Okay. Paano na yan, class? At state 2. State 2. So, isothermally, temperature 1 is equal to temperature 2, 200 degrees Celsius. But the given pressure now, may pressure dun, class, oh. Ay, pressure 2 pala. 515 megapascal. Pressure 0.25. 5, 1, 5. Ay, point. Ay, bakit ganito? So, this is 0.515 megapascal. Expands isothermally. Okay. So, the table 2, let's find this. Anong gagawin natin dito, class? Given sa atin, expands isothermally. Bumaba yung pressure natin. Diba? Ay, ito yung bumaba. Point. Ang magiging reference natin, class, is 0.515. So, paano mo mako-consider to, class? So, basta class constant yung temperature natin, ha? So, para mapakita ko sa inyo, at table 2, sa saturation pressure, yung pressure natin between, hindi ko na-elaborate, between 0.5, page 10, makikita niyo doon, 0.5, 515 tayo eh. Dito tayo, 0.1, okay. So, dito class, makikita nyo at pressure, 0.51 and 0.52. So, nagpo-fall dito yung 515. Ang saturation temperature niya is ilan? 151.8, 152. Duduling si ma'am. So, 152.6 and 153.30 po. Okay. Take note, mas malaki, kahit hindi natin to interpolate yung temperature at 0.2, makikita nyo class dito sa mga values nila. So, ang values ng temperature niya nagpo-fall between this value. But, yung temperature natin to is greater than this one, the T-sat. Automatically, this is a superheated vapor. Okay? Superheated vapor. Ayan. So, pupunta tayo doon sa table 3 with the given pressure na 0.515 MPa as well as temperature to natin na 200. Okay? Anong page siya doon? Page what? Napin na natin, 515.51. 0.515. Mag-double interpolation ba tayo? Ayan, wala plus na. Wala. Okay, double interpolation tayo. Double interpolation, hindi naman. Mabuti lang hindi double interpolation class. Sa susunod, may double interpolation na to. Okay, take note. Punta ka sa page 31. Makikita mo sa taas si 0.5 and 0.50 and 0.52. So, nagpo-fall yung, excuse me, yung pinapahanap sa atin is 0.515 MPa. Okay. Ano muna yung given? Punta ka dun sa 0.5, 0.52 at 200. At 200. Okay. Sige. Isulat mo na ni ma'am lahat para madali mag-interpolate. Yung specific volume natin na times 10 to the negative 3 cubic meter per kilogram. Yung enthalpy natin, hindi enthalpy, U, yung U natin into kilojoule per kilogram. Yung H natin, kilojoule per kilogram, and yung entropy natin, kilojoule per kilogram Kelvin. Okay. Dito muna tayo sa page 31 sa 0.5 column at 200. Nasusundan ba ako, class? Raise your hands if nasusundan si ma'am. Okay. Okay. Thank you, class. So, dito na tayo sa 0.5, 429.9. Yung H natin, ay yung U natin is 2642.9. Ito, 2855.4. We have 7.0592. Dito naman sa 0.52, we have 408, 2642.1, 2854.3, and 7.03. Okay, so we have now those values.
Hello po.
Yes po.
At 4 to 4.9 po yung ano, yung sa
Alin?
volume po nung 0.50 po. 4 to
Ano
4.
yung lagay ko? Ay,
4 to 4 po.
pasensya na, class. Thank you. For sabi ko na sa inyo, class, naduduling na si ma'am. Ayan. Ano pa, class? Pakicheck nga. 4 to 4. Pakicheck. Thank you, Jed. Okay. Other, my dear student, alin pa? Double check. Ayan, naduduling na si ma'am. 424, 264, 2.9, 2855.4, 7.0592, 408.1. Kaya class, double check nyo bago kayo mag-interpolate, ha? 2642, 2854.3, and 7. Okay, thank you, class. So we will now compute the different state points at point 2. Okay? At the given temperature at point 2. So what is now the specific volume at point 2? You just need to interpolate using this value. Sige nga, hindi ko papakita. Papakita yung how do you, ano yun. Sige nga, paano mo makukuha yung specific volume at point 2? Class? Solve it now. Okay, now. Bilis ha, may sagot na. Sige nga, tingnan nga ni ma'am. Yung iba. Ayan, 0.515 minus 0.5, 0.52 minus 0.5, 3/4. Okay. Minus. Ayan. Maingay na naman dito sa aming bahay. Anting bahay. Baka malito kayo kasi baka mabaliktad nyo. 408.1.9. Okay. So, bakit? Ano yung mga sagot nyo? 412? 412 ba? Bakit sa akin iba? Ano class yung answer nyo? Po, class. Ako, ito yung answer ko iba. Okay, 412. Yung iba, sige nga, class, pa-double check nga yung iba. Baka malito kayo, class, ha? Ano ko lang, ha? Yung pinapahanap natin, alpha x or 24.9. Yung iba, hindi na alam mag-interpolation kahit hindi sinulat ni ma'am yung equation. Alam? Okay. So, pag ginayan mo yan, class, 95. Ayan. So, we have 41. Okay. Di po ako nakakasunod, ma'am. Sige. Masyado bang mabilis si ma'am? Okay. Sige. Sige po, class. Masyado mabilis. Okay. So, punta ulit kayo, class, dito sa table 3. Yan, class, page 31. So, dito pa sa taas, makikita nyo is 0.5 and 0.52. So, wala yung given sa atin na 0.515. Since superheated vapor siya, pupunta talaga tayo sa table 3. Okay. So, dalawa yan, class. After that, looking at the upper corner of sa page 31, nakikita mo yung pressure. Dito naman ka in your right corner ng book, makikita nyo yung saturated temperature. Hindi ito saturated. But this is now your given pressure. At a given pressure na 200, hahanapin nyo sa gilid yung 200. And then, makikita nyo na yung mga values niya. Okay. So, hindi pa to double interpolation. Isahan pa lang tong interpolation. It's just that ang orientation niya is iba dun sa mga saturation pressures. Okay? Sige, sulat na nga. So, ang mangyayari class ganito. We have now the 0.5. Ayan. Kasi masanay kayo dito. 0.52. Ito yung nakita nyo. And yung specific volume at point na, at that specific point, we have 424.9 and the 408.1. Okay. So, ang hahanapin natin dito is si 0.515 kasi wala siya sa table. Hahanapin natin si specific volume at 0.2 wherein na-compute na ng classmates natin times 10 to the negative 3 cubic meter per kilogram. So, parehas lang class mag-interpolate ka dyan. Kung paano tayo nag-interpolate doon sa ganun din class. Okay? Okay, punta na tayo doon sa internal energy. Okay, sa internal energy naman class, yan, paki-compute na class yung mga para pakita ko lang yung orientation sa mga classmates natin. Yan, 2642. Ayan o. Ibig sabihin kasi ang value, kahit hindi ko ito double check, dapat ang value nagfo-fall dito. 2642. Sa decimal lang siya magbabari. Okay? So, the answer now is 2642. At this point, we have 2642.3 kilojoule per kilogram. The internal energy natin is 2642.3 kilojoule per kilogram mass. Yes, thank you class. And also, dito tayo sa enthalpy. Kung ayaw ninyo class ganito, kasi ganito yung sa table orientation sa table 3, pero yun din gawin ito, ganito yung dati, para mas madali mag-interpolate. Opo. So, we have now the enthalpy at 0.5, so we have 2855.4 and 2854.3. Ibig sabihin, nag-fall lang dyan yung mga values nyo. Ilan yung answer? 25, 2854. Oh, bakit iba-iba? Ako nga ang mag-compute. Sige nga. kayo talaga, class. So, x minus 2855.4. Double check. 2854.3 minus 2. Okay, what is your answer? Ano yung answer ko? 28. Ayan. Your enthalpy at point 2 is 0.2. Masagot nyo, class. Ayan, 2854. Okay, 2854 ba, class? 2854. Okay. So, ang answer ni ma'am is also 2854.58. Tama ba? Ayan, nakuha niyo naman, class. 58 kilojoule per kilogram. 2854.58 kilojoule per kilogram. Punta tayo sa entropy. Entropy. We have now the entropy. Ay, wow, gagaling na. 92, we have 7 point. Pakita ko lang sa mga classmates natin kung para hindi sila mahirapan mag-interpret. Sige nga. Ayan, double check din yung mga minus 0.592, 7.03949, or minus 7.0592. Okay, so your answers are correct. 7.044 kilojoule per kilogram Kelvin. So we have now the different state points. Ayan, 44 kilojoule kilogram Kelvin. Okay, meron na tayong point. State 1, state 2. Okay. Ano yung pinapahanap? The change in entropy, the change in enthalpy, and the change in internal energy. So, since sa problem class, take note sa problem, given sa atin yung letter A, given. Ano yung given sa problem? Steam at 200 with an entropy expands isothermally for a 5 kilogram. Tingnan nyo, may kilogram na siya, class. So, we need to take note of that. What are the change in S, the change in H, the change in U? We need also to determine the heat and the work of the process if it falls under the non-flow process and the steady flow process where energy is 0. Okay? So, the given, ayan. Ang given is mass is equal to 5 kilogram. Pag may given na mass, automatically, kadalasan, capital na yung pinapahanap. We have now the change in S is equal to the mass times the change in entropy. S2 minus S1. What is now the mass? 5 kilogram. What is the entropy at point 2? 7.044 kilojoule per kilogram Kelvin minus the entropy at point 1. Given yon. So we have 5.6105. 5.6105. Ayan. Ayan. So compute for the entropy, class. For a given mass na 5. Ayan. 5, class. Ay, answer nyo. 0.044 minus. Anong units? Double check ko nga. Baka hindi na naman yan. Sigurado? Okay. Take note ang magiging units na natin. So, ano yung units ni? Sigurado kayo? 7.1695 kilojoule Kelvin. That is now your units kasi makakancel si kilogram. Yan, makakancel na klase kilogram. Okay? Thank you. So, proceed tayo sa change in enthalpy. So, capital na yan, class. Pag may ano na, class, capital H na. Pag may mass na po tayo. Okay, so 5 kilogram. We have 5 kilogram times the H2. We have here the 2854.58 kilojoule per kilogram minus the H1. Ayan. Ito si H1. Okay, what is now the change in enthalpy? What is now the change in enthalpy? So we have to 2854.358 minus 0.23. So we have now 450.35 times 5. Kakalimutan yung 5. So we have now 2,251.75 kilojoules. So take note of that the units is still in kilojoules. Kilogram, makakancel na yung kilogram. Okay? Next, we proceed on the enthalpy. Yes, nakuha na natin yung enthalpy. Thank you, class, for participating. Next, we find the internal energy. The internal energy mass times the internal energy at 0.2 minus the internal energy at 0.1. So, 5 kilograms. So, we have the internal energy at 0.2. This one, 2642. 2642.3. So, kung nag-present ng solution din yung task. And the internal energy at 0.1, saan? 2, 2, 2. Ayan. Bakit kinuha natin yung specific volume? Anyways, pag kailangan sa problem. Okay? So, 2, 2, 45, 71. 2, 2. Oh, ang bilis nyo class. Ano yung state 1 natin? Nalulugod sila. 45, 71. 2, 2. 45. Sure. Bibilis nyo 2, 6, 42. 2, 2, 45.71. Yan, times 5. Yan, times 5. Tama ba yung mga sagot nyo, class? Baka. Ayan, very good. So, we have now 1982.95 kilojoule. Okay. No, cancel mo yung mga units natin. We have now the first given. We need also to find in the question class, we need to also find the heat and the work. So, ito yung B class, pinapahanap sa atin yung heat at the same time sa work sa non-flow process. Okay. Take note sa non-flow process. Since this is a constant temperature, pag constant temperature class, ito yung gagamitin natin. Okay? Since we all know that the temperature is ano? Ang temperature class natin is 200 degrees Celsius. Convert it first into Kelvin. Sige nga. Anong gagawin niyo para maging Kelvin yan? So the temperature now is equal to, what will you do? Yes, you just need to add 273.15. So the temperature is 473.15 Kelvin. So the Q is equal to 473.15 Kelvin. Since nakuha na natin yung change in S, the T times the change in entropy, here class sa taas, this 7.169195 1695 kilojoule Kelvin. Automatically, we have now the transferred heat in kilojoule. Maka-cancel si Kelvin natin. Okay? Answer. Bibilis, ha? Daya yung class, ha? Okay, we have now 3,000. Bakit iba? Ay, wait, naduduling ba ako? 3392 point, ayan, 3392.25 kilojoule. So we have now the heat, the transfer heat at Q, as well as yung work naman class sa non-flow, gagamitin natin yung simple energy equation natin na Q equal to the change in U plus the work of the non-flow. So we have now the work non-flow is equal to Q minus the change in U. We have solved this, the 3392.25 kilojoule. Take note class, magiging domino effect na to. Pag mali ka pa lang sa interpolation, mali na lahat ng solusyon mo. Kaya, please be careful. Minus the change in internal energy, 1982.95. Ayan, 9, ito. 82.95. Tama ba? Ayan. Kilojoule. So the work of the non-flow now is equal to how ilan? Minus 1982.95. Okay? So we have 1409.3 ba? 30 kilojoule. Okay? So meron ka na sa letter B pag non-flow. Sa letter C class, sa steady flow process, yung heat natin class is parehas lang kasi wala namang sinabi doon na maiiba. So, surat nyo lang. But in the work of the steady, so babalikan natin yung equation natin sa isothermal process. Diba class? Yung sa isothermal process natin, ano yan? Is Q, the heat, minus the enthalpy, minus the Kelvin. Kelvin man sa. That is the change in kinetic energy. So, since sa problem class, the change in kinetic energy daw is equal to 0. So, the work of the steady is equal to the Q, 3392, minus the H. What is the H? Here, 2251.75. 2251.75 kilojoule minus 0. So this is now the work in steady flow process. So ano yung class? 3392.25 minus 2251.75. So we have 144 kilojoule. Ayun, class. So that is the constant temperature. That is now the constant temperature process, the isothermal process. Okay? So, yun class yung isothermal process natin. So, next meeting class Monday, we will proceed to the adiabatic, the polytropic processes. Okay? So,
Tuesday po ang next meeting.
ay, opo pala, EDA pala yun. Okay, Tuesday po. Okay, class. So, practice more problems involving adiabatic processes. So, ito na class, the adiabatic and the polytropic. Polytropic processes. Pag natapos natin yan, magra-rankine cycle na tayo. Okay? So, okay, thank you, class. So, can I have everyone... Ay, may questions pa ba? Yan, may questions pa ba, class? Pag may question, just PM si ma'am kasi maingay yan dito sa bahay. Okay? Ay, yes! Okay. Diagram. So, balik tayo dito since, yan. Okay. So yun sa diagram class, di ba, nalaman natin that on the first state, that is a wet mixture, and 79, di ba, 79, so malapit-lapit dito siya class sa, malapit siya dito sa may linya because that is 79.99 or it is in 80%. So, since this is in an isothermal process, di ba class? So, 79. So, dito tayo. So, here, 79. So, this is 0.1. So, paano class yung pa-point? So, since this is a constant thermal process, pag ganito ba class, sabi ko? Ayan. Iba yung given pressure at 0.1, iba din yung given at. Ayan. Sige, dito na lang. At pressure at 0.2. So, this is 2. So, this is now your diagram at 0.1. Ang pangit, class. Okay? So, yan, class, yung magiging diagram natin. Kalimutan ni ma'am. Sayang ng 10 points. Okay. Next, class, sa TS diagram, since this is a 79, sabi ko nga, iba yung pressure at 0.1. Iba din yung pressure at 0.2. Since yung temperature class is constant, di ba? Constant yung temperature natin. So, from here, ito yung temperature natin na 200 degrees Celsius. So, from 0.1 na 79, dito yon. And superheated siya at the 0.2. So, this is now your diagram here in the second process. So, ito yung pressure at 0.1 and the pressure at 0.2. Okay. Di ba yung saturation pressure ni 0.2 mas mababa kasi 153, 155 something class sa steam table. But since ang given sa kanya is constant daw yung temperature, automatically, it is considered as superheated. So, nagpo-fall din yung 0.2 natin at the superheated region. Naintindihan na po ba, class? Okay. Thumbs up or raise your hand if you understand now the constant temperature process or the isothermal process. Okay. Yeah. Thank you, class. Okay, so that is the yung presentation class na nakalimutan ni ma'am. Huwag yung kakalimutan kasi yung PV and PS diagram, okay? So, thank you, class. So, this is now for just today. Dalawa munang process, the constant temperature, the isothermal, and the isometric processes. Okay, class. Thank you. Okay. Nasaan yung iba? Wait lang. Class, para tapos na tayo, can I request everyone to open their camera? Ayun, naka-recording kayo sa aking laptop. 3 gadget ang gamit ko ngayon, class. Sa laptop, and sa iPad, sa cellphone. Okay? Stop recording ko.